What is f sub y evaluated at 0, 3? 6. Okay. Notice that's not 0. Ian, I'm glad you chose, or I don't know if it was you or what. Will, was it you?
No, it was you.
Okay. I'm glad you chose that one. Because in this case, see, all the assumptions of the implicit function theorem are satisfied. Notice f sub y is not 0. We would have been in trouble if this had been 0. So what this means is this. You can find a neighborhood around this point in which y is a function of x. So you can define a small neighborhood around x where y is a function of x. And what is dy dx? Dy dx is just this. The way to remember this is if you want dy dx, then the f of x is going to be, capital F of x is going to be up here. And the capital F of y is going to be down here. That's how. So what is the slope here? Well, it's minus 0 over 6 or 0. So dy dx is 0 there. It might help if we look at this graphically. What is, if you graph this capital F function, what does it look like? I should call it a relation. If you graph this capital F, what does its graph look like? Did Andrew remember? Yeah, just a circle. Because we have one point here. If x is 0, y is 3. Actually, to be a little more precise, what would be another value of y that would have worked? Negative 3. Because negative 3 squared is also 9. So actually, there's 2 points. 3 and minus 3. And there's also these points. If x is 3, if y is 0, it would be right here. If x is minus 3, y is 0. And if you connect all these points, it gives you a circle. So what the implicit function theorem is saying is, if you pick this point right here, there exists a neighborhood around 0 where y is a function of x. Actually, there's 2 different functions. There's this one up here, but there would also be a function down here. But we picked that one here. And notice that we would have been in trouble. Had we picked x equals 3, what would have been the problem? Let's redo this. Suppose we picked x equals 3. Then what is the value of y? 0. Okay. What is f of x?
6.
What is f of y? Right. Then we have a problem. Because part of the implicit function theorem involves this assumption that capital F sub y is not 0. You can see what the problem is. See, if you pick this point right here, you can't go any higher because you've got to be on the circle. But you could go to the left. But if you go to the left, then what happens? then there are two different values of y. So in this, the only point you can't pick is x equals 3 or x equals minus 3. Because then there's no neighborhood around this point where y is a function of x. So as long as you don't pick one of those extreme points, x equals 3 or x equals minus 3, there's going to be a neighborhood around x where y is a function of x. Another way to look at this is, let's rewrite this equation. You could rewrite this equation as y squared equals 9 minus x squared. And take the square root of both sides, and then you would get this. And realizing that a minus number or a plus number of y gives you the same. So the solution is y equals plus or minus the square root of 9 minus x squared. So this upper half right here is really the function y equals the square root of 9 minus x squared. And this lower half is really the function y equals minus the square root of 9 minus x squared. So there's really two separate functions. So you could have picked this one. If you pick your initial point, x equals 0, y equals 3, you're around this one. And then this equation right here describes y as a function of x. Now, had you picked this point down here, then our function would have been y equals minus. And that's the function right there. Yes?
Maybe something's just not clicking for me, but I don't understand why we can't say that y is still a function of x at point 3, other than the rule that you gave us. I still see that point there,
Well,
0 or 3, 0 being given
see,
by that.
yes, okay. Now, the theorem, maybe I didn't state it quite precisely. It means you can find a neighborhood around x, a neighborhood around x where y is a function of x. And in this entire neighborhood, this y equals f of x has the status of an identity. So if you just pick x equals 3, then there's only one point. There's just one point. And there's no neighborhood around that point where y is a function of x. See, if you pick this point right here, 3, then you can't go to the right because you have to satisfy that capital F equation. So you have to be on the circle. So the only way you could go is to the left. But if you go just a little bit to the left, then there are two values of y. There's the value up here and the value there. So y is not a function of x. Okay. Let me give you another example. And let me also kind of motivate this in a simpler way. When I first solved this, the way I learned it was slightly different. Suppose we have this equation right here. If you take the total differential of this equation, what is the total differential of this equation? Take the total differential of this equation, what do you get? Okay, but what's the left-hand side? Just write it out. In general, what's the total differential? How would we write out the total differential of this? Well, by definition, the total differential is what? The total differential of capital F. Yes,
a partial function with respect to x times dx plus,
Right.
and then same for
Right.
y.
Right. The definition of the total differential of f is just this. Let me write it as just f sub x. Partial f, f sub x. Times dx plus f sub y dy equals 0. And now, let's bring this term over to the right. So then we'll have f sub y dy equals minus f sub x dx. Now let's divide both sides by dx. We get f sub y dy dx equals minus f sub x. Now let's divide both sides by f sub y. And then you get dy dx equals minus f sub x over f sub y. Now, when we do this, we're implicitly assuming that we can find values of x and y that will satisfy this equation. We're also implicitly assuming that capital F sub y is not what? 0, because then that would be undefined. That's another way of thinking about the implicit function. Let's, since this is a new concept, let me just break at this point and give you 3 homework problems to work on. You get stuck, just please ask, and ask your neighbor, ask me, and we'll help you through. Look on page 204. And look at problems 1. Let's start off with problem 1. Take a few minutes, see if you can work through those 3 problems, A, B, and C. And if you need help, have questions, feel free to ask. For this first one, if I notice, we have this, I'll put in the capital F of x, y. What is the first step in the implicit function theorem? One would kind of ignore, but what's the first step?
Take the partial x1.
Right. F sub x, that is equal to what?
Minus 6.
Right. F sub y
1.
is equal to 1. Are those functions continuous? Yeah, you graph them, they're just horizontal lines. There's no holes in them. They're continuous. So that's satisfied. So what would be the next step?
But, minus f of x over f of y.
Oh, well, let's go back to the theorem. Can you find a point satisfying this equation?
Oh,
Can you find a point satisfying that equation right there?
Zero.
Anybody?
0 for x and negative 7 for y.
Okay. If x is 0, that's a nice one, like that drops out. So y minus 7. Okay. That will satisfy. And what do you know, what's interesting about f sub y? Capital F sub y. It's not 0. It's never, in fact, it's never 0. It's always 1. So, you found a point satisfying this equation. And f sub y is not 0 there. So, that means you can express y as a function of x. You could find a neighborhood around, say, x equals 0, to which y is a function of x. In fact, in this case right here, you could see, if you just transfer this over, what's another way of writing this equation? We know by the implicit function theorem, y is a function of x. And in fact, you can see what that function is. What is that function?
6x minus 7.
6x minus 7. So it's a simple linear function. And what is dy dx by the implicit function theorem?
Negative 6 over 1.
Okay. Or more generally, by the implicit function theorem, dy dx is what?
16.
More generally,
Minus f of x over f of y.
it's
Back-
minus f sub x over f sub y by the implicit function theorem. Now, what is f sub x? Minus 6, but you got a minus sign, so it's 6 over 1 equals 6. Which is obviously in agreement with this, because what is dy dx? 6. So for this first one, it was really quite straightforward. But if you run through the steps of the implicit function, some of the problems will be much more complicated, and you won't be able to explicitly solve for the function. Nevertheless, this formula right here will give you the right answer, as long as the assumptions of the implicit function theorem hold up. Well, let's look at the next one. Let's look at the next problem. Well, I don't know. The next problem is pretty simple too, isn't it? Let's go to part C. Number A and B, they look too similar. Let's go to part C. In part C, we're given this one. X squared plus 6x minus y. Oops, minus 13. Minus y equals 0. Okay. Now, is y a function of x? First, we should really look at that. Is y a function of x? What's the first step?
Well, we could just take the partial derivative of y, see that it's not 0.
Well, it wouldn't even be the partial derivative. What you're saying is we could rewrite this and solve for y explicitly. Couldn't we? By just bring the y over. And then you could directly, see, whenever you can write out y equals a bunch of terms involving x and y as a function of x. But, let's use the implicit function here. What's the first step of the implicit function here? Suppose you didn't see that, Jake. It's pretty obvious, but suppose you missed that.
I thought the first step for taking the partials,
Right, it is.
so.
Right. So what is f sub x? Oh, is that what you were saying, Jacob? Maybe I misunderstood. I'm sorry. Okay, okay. You're right. Take the partial derivatives.
So we can see that.
So what is f sub x?
2x plus 6.
I'm sorry, I misunderstood you, Jacob. I was thinking of something else. Okay. Nice linear function, continuous. What is f sub y? Minus 1. Again, horizontal line is a continuous function. Furthermore, f sub y is never 0, is it? So if you could find a point satisfying this equation, then there exists a neighborhood around that point in which y is explicitly a function of x. So then all the assumptions of the implicit function theorem hold. If you could find a point that satisfies this equation, one obvious one would be x equals 0. That drops out, that drops out. And y would be minus 13. So that would be a point satisfied. So we can find a neighborhood around that point in which y is a function of x. Furthermore, what is dy dx by the implicit function theorem? By the implicit function theorem, dy dx is what?
Negative f(x) over f(y).
Yes, it's negative f of x over fy. And if you just plug in, notice a minus 1 would be a plus 1. So the answer is just going to be 2x plus 6. And that is dy dx. Now in this case, a simpler way of getting dy dx, and I thought that's what you were trying to do, Jacob. What would be a simpler way of getting dy dx without using the implicit function theorem? Okay, just move y to the other side. And then you get y, let me put it on the left. Y equals x squared plus 6x plus 13. And then differentiate this and get dy dx equals 2x plus 6, which is comforting, it's the same answer. Now, in more complicated problems, you are not going to be able to get d by dx this way. For example, look in the book, in the same section, same page. Let's try to do problem 2a. Look at problem 2a and see if you can get dy dx. Just in case you don't have your book. 2a is this problem here. Capital F of xy equals 3x squared plus 2xy plus 4y equals 0. Now the question is, actually you could ask two questions. The book just asks, find dy dx. In order to find dy dx, though, the assumption is, in order for dy dx to exist, y must be a function of x. So you really have to use the implicit function here. So, Jacob, how do we proceed?
Let's take the partials.
Yes, take the partial derivatives.
fx is equal to 6x plus 2y.
Yes. And that's a simple linear function, continuous.
Fy
F sub y,
is equal to 2x plus 12y,
okay, so it's a 2x
y squared,
plus, what'd you say, Jacob?
so 12y squared.
Right. Again, that's nice continuous. Anytime you have a polynomial function, it's going to be continuous. So both of those are continuous. So we would need to find a point satisfying this equation. This is a little trickier, but if you have a calculator, you might try something. Well, what would be the most obvious point? And we'll run into problems if you use the most obvious point.
0, 0.
Yeah, the most obvious solution would be this. This point will satisfy it, because that's 0, that's 0, that's 0. But what is f sub y there? 0. So we can't use that. So you need to find another point. You might try something like, I don't know. Anybody have any suggestions? I don't want to spend a lot of time on this, but.
So in this step, do we have to just work muscle through this part with the points? Is there no other way to come up with the points?
Well, no, not really, but you just have to find one. Right. You just have to find one. But, oh, okay, let's try this. I don't even know if this will work. Let's try something simple. Try this. If this is 1, we'll have 3 plus 2y plus 4y cubed equals 0. Okay. So, could anybody tell me what the value of y is there? Sometimes it's a little bit tricky. Sometimes there's, okay, I'll let you work it. Let me just assert. I will just assert that you can find at least one point that satisfies this. Okay. So let's just avoid muscling through, Jacob. So you would obviously, let's see, if y were positive, that'd be positive, that'd be positive. This would be a -3, so that would work. So it looks like you'd have to choose a negative value of y. Yeah, choose a negative value of y, because this term would be negative, this term would be negative, and I'll just assert that you can find a value of y that will satisfy. Yes.
I'm probably just missing something obvious, but I don't understand why we have to find a point.
Well, see, the whole starting point, Tyler, is this. This is equal to 0. But suppose there are no values of x and y that actually satisfy that equation. Then, for any given value y, there's going to be no value, or excuse me, for any given value of x, there'll be no value of y. So that's why you have to have one point that at least satisfies it. Because that's really the starting point. You're assuming, when you write this equation, you're assuming that you can find at least one point where that equation will be satisfied. Because that's the equation you use to define y as a function of x.
Okay, and then it's still possible to be able to find a value, or
Yeah.
to define this relationship, even if there are no points?
No,
Could be-
that's my point. How can you find y as a function of x if there are no points that satisfy that equation? Then
Yeah, I don't.
there would be no values of y that
Mhm.
would satisfy that equation.
Yeah, I'm talking about, wow. not exactly sure how to
Okay,
articulate that.
see,
but-
this is, well, let me think about how I can better answer it. But this assumes that there
No,
are
no.
values of x and y that satisfy this equation.
No, I understand what you mean there. I'm
Yeah.
thinking about,
Let me take a similar case. Let's take this case right here. I think maybe this will help you. Suppose we have this. And what is the problem here? See, if you solve for y as a function of x, it means for different values of x, this function will tell you the value of y. But in this case right here, what is the problem? What is the only value? There's only one value of x and y that'll satisfy this equation. What is it?
0, 0.
Zeros. So this is the only solution. So the whole idea of the implicit function here is to express y as a function of x. So that means there has to be several values of x and y that satisfy the equation. Because in this case right here, how could you write y as a function of x? The domain, the value of x that satisfies that equation is x equals 0. So that's a single point. So that would be very interesting.
Yeah, no.
So what we want is a function that'll give us the value of y for different values of x in the neighborhood around x of 0.
If that's true, then would finding one point be sufficient, or would we need to show it to be the case over an interval?
Well, all you need to do is find one point, and you need f sub y not to be 0. So see, the problem here is we did find a point that satisfied it, but what is f sub y? F sub y is equal to 2y. And at the critical value of x, or the value of x and y, that's 0. So the implicit function here is called. See, there's just a singleton. X equals 0, y equals 0. There's no function. Y is a function of x. You need a neighborhood around x of 0 in which you can express y as a function of x. But there's no neighborhood around this. This is the only point. Satisfies it. Or if you go back to the first example, where we had this circle. What was our equation? Y squared plus x squared minus 9 equals 0. So we could pick any value of x, so long as it wasn't this one or this one. Because see, if you try to take a neighborhood around x equals 3,